Okay, good evening, everyone. How are you? Good? You like this space? I like this space. This is actually the first time I'm up here. Anyways, my name is Chen, and I'm the lead on the Electrode platform here at Walmart Labs. Today I'm going to talk about how Electrode integrate with Walmart Labs infrastructure and provide the development with new technologies like Node.js and reactjs for developing an e-commerce site at the scale of Walmart.com. So, about scale, let's talk a little bit about scale. So if you just have a couple thousand or tens of thousands users and visits to your site every day, you probably can run your site on a single server. I mean, these days with the server so powerful, you probably can run it on a shared, dedicated virtual server. You can run your database and your web server all on the same machine, and you'll be able to handle that kind of user base. But when your traffic looks like this, we have millions and millions of users and traffic, it's going to be a completely different game. It's going to require a very large and complex infrastructure to handle that kind of traffic. So I'm going to quickly go over Walmart Labs infrastructure first and show you how it's like. It's pretty standard actually. We run our own data centers with tens and thousands of servers. We also support multiple clouds with a very large load balancer and NetScaler and failover switching. And I mean, on Black Fridays, one of our biggest problems is actually our NetScaler cannot handle our internal traffic. I mean, we have, say, maybe 10,000 machines all trying to talk to each other. The failing point is like, it's usually the NetScaler that cannot handle. I mean, that's a $500,000 equipment there, and it cannot handle that kind of traffic. It's like you are talking about 10 gigabit of traffic, and we cannot handle that. So we also developed our own in-house OneOps cloud platform. It's based on OpenStack. It's actually open source. You can check it out at oneops.com if you like. With that, now we have to look at how we can deliver content to our users. So in-house, we have a few things to accelerate content delivery. We have an in-house tool called Torbit for acceleration content delivery. It's implemented in Golang. So we actually have a very big Golang user base here. So if anyone's interested in Golang, we do have a very big Golang team here. So Torbit, what it does is that it sits at a routing layer. When the content we return to the user, it's basically pretty much usually HTML. It goes through Torbit. And Torbit does static analysis on those HTML content and figure out what kind of data can be static, what kind of data can be dynamic, and figure out what to cache and where to route things. We also run our own static content servers that's connected to the internet directly for delivering static content like JavaScript, CSS, fonts, images, and anything that's meant to be static. Finally, we have a partnership with Akamai all over the United States and all over the world to optimize regional content deliveries. In the back end, we have a microservice architecture. Microservice mainly for retrieving data from the database and generate the content for the front-end apps. The microservices are running on top of JVM, and it's usually implemented in Java or Clojure. So we do have a pretty big Clojure team here, and recently they just open source named Lacina, I think. It's a GraphQL library that's implemented in Clojure, so you can use GraphQL in JVM. So we can get data out, but now we also have to get data in. We usually actually get more data in than we send out. Maybe not. But we need to get data in because we need to have instrumentation and monitoring data from our applications, so we can figure out what's happening on our site and what's happening with our apps in case if there's any issues, we have to make sure we respond. We do have multiple channels. We have service with Splunk. We are one of the biggest customers. And we are always on the edge of overstretching their capacity, actually. We do have an in-house Greylock cluster. We also have a Kafka cluster. And these come with nice dashboards for plotting graphs, real-time graphs, so we can monitor in real time what's happening with our apps. So that's a quick summary of our infra, data center, cloud platform, content delivery, microservice, and reporting. So next I'm going to take you to the Electrode's backend to see how Electrode helps integrate with all that infrastructure Walmart Labs has. Most of these actually are Walmart Labs specific, so they're not open source. First is Selenium Integration. If you check out our one Ops project, it's open source. It actually offers pretty nice web-based UIs that allows our developers to go and just kind of choose and pick and create a VM instance or platform instance inside the cloud. But it's a very manual process and it's very error-prone. And Electron platform was meant for our developers to develop, say, a couple dozens of apps. So we cannot expect every team to go and manually create their own VMs in the OneOps cloud. So the first thing from Electron is a bunch of shell scripts, actually. These shell scripts offer a single command to our developers. They run the command and boom, they get an instance in the cloud, and then they can just write their app and deploy, and everything's taken care of for them. Also, Electron offers a continuous build, test, and deploy pipeline, so our developers can just focus on developing the app and let Electron take care of the rest. And so, for the microservices, most of them implement in Java. So before Node.js came along, all the clients were implementing Java. To help our teams to connect to these services, the first thing Electron did was standardize on consuming services with Swagger. The clients are dynamically generated from the Swagger spec. That way, our developers don't even have to worry about any of the internal information about how to call these services. They just describe their service endpoints in Swagger, and Electron would load that spec, process it, and then automatically generate a dynamic client. Also, by standardizing on these clients, we are able to share these service clients across all our teams. So it's a collaborative effort. Now, internally, we have probably about 20 to 30 service clients that was built by all our teams. Any team who comes along, if they need to connect the service, the first thing is they check, is that client node, and they will build one, and pretty much just describing the service in Swagger spec. So with a complex cloud, configuration is always a requirement. Even if you just you just deploy to a single cloud, you still have your local environment that you have to probably handle differently. Maybe you have marketing services or whatnot. For us, we actually have 3 different clouds. One is for development, one is for staging, one is for production. The development is usually for developers, staging, for QA, with more stable backend services, and production, of course, has to be very critical. So to maintain a similar parameters for all these different environments, we created a new module called config. It's basically similar to a node module out there called node config, but it's more flexible. With config, you can actually generate settings from different cloud based on the different cloud environments. Once it's properly set up, the apps would behave correctly on all the different environments and stages. So our developer can just focus on writing their code and let Electron take care of the rest. And deployment, how we deploy our Node.js app to the VMs. It's a fairly standard setup. In the front end, we run a HTTP proxy Nginx, listening on port 80 as root. And Nginx will forward all the requests to the Node application running in user land. We use PM2 to manage our application and run multiple instances with the Node.js cluster mode. Okay, so now, getting data back into our clusters. For matrix reporting, Electrode actually deploys a separate process, or Electrode APM on every VM. And the Node application, all the instances would send events locally to this process, and this process would aggregate the events and send them to our Kafka cluster. Okay, so that's the Electrode backend. Next, I'm going to go over some of the Electrode front end and how we build Walmart.com in React. First, let's take a look at how our Walmart.com site is structured. We have a couple dozen of apps that's powering Walmart.com. Usually, each app will handle a specific dedicated area of the site. For example, here is that we have the landing page served by a home page app. On most of the pages, on top there's a search bar. That's serviced by the search app. When you search for something like Legos, then you'll get back the result that's served by the search app. And if you click on one of the items, you'll get the item page that's served by the item page app. Together we have I don't have any official number, but I think we would have hundreds of developers working on Walmart.com. And right now, most of Walmart.com is powered by apps developed in Electrode. Here is a list of some of the more common ones, like homepage, search, item, account, cart, and checkout. That's usually the flow that our users go through when they are trying to buy something. Okay, so let's take a look at the before and after technologies. Before Electrode, our web apps are developed in Java with the Spring Webflow. The HTML built in handlebars template with jQuery and backbone. It was getting very difficult to maintain. I mean, just setting up a development environment could take days. So with Electrode, it's all Node.js and reactjs. So now we have, on the front end and the back end, we have a single JavaScript ecosystem. And as you know, Node.js, it takes only minutes to set up, so our developers can just get up and running and start developing in a matter of a couple minutes. And Electrode introduced a new concept called Archetypes. Archetypes are just NPM modules that contain standard stuff like configurations, build and test scripts, and application usually will just consume the archetype as a dependency along its other dependencies. This way, we can actually fix and enhance our build scripts and test scripts in the archetype module, and the application will just need to update its dependency. It will get all the updates and fixes. Electrode right now offers 3 different archetypes that are open source. One for building React app, and then next for React components, and finally a fairly simple one for building node modules. So with the archetype, it's pretty easy to just develop a React application. But still, you have to manually set up your app structure, make all the directories, install the archetype dependency. So we made that easier by offering a Yeoman generator. Assuming that you already have Node.js installed, you will just need to do npm install globally a few of the modules, particularly generator Electrode, and you just run your Electrode. The only thing you need to provide is probably the name for your application. Everything else you can just press enter for the default. After that's done, then you will get an Electrode application, and you can just run clap dev, and it will start the application in development mode, then you can open it in your browser and you will see this page. This is our demo components for the app that's generated. Once you have the app and you get in the development mode, you can just start writing your React code. And as you write your code, it's going to be passed to Webpack and Babel and process and bundle. Then you can test them in the browser or run your tests in Karma and Mocha. The next big thing from Electron is Universal React. Universal React is basically means that the same React code you write will work on the server and on the browser. This is made possible by React's render-to-screen API, and it's known as server-side rendering. We need server-side rendering because we are an e-commerce site and we need SEO. But with server-side rendering, actually, your user get faster visual display because you return a literal HTML that the browser can understand immediately before it loads your React application. So once the browser will display the HTML literal and then load your React application, once the React application starts up, it picks up with the server-side rendering left off. And for any website, it's pretty standard that you need to deal with configuration, probably cookies, and login information back to your server to know what's going on. And if you only need to do these things on the browser, it's usually pretty easy. Pretty straightforward. I mean, you can just access cookies and you can just send a config. But if you need to make this work on server and on client, it's pretty tricky. So to solve this, what Electron does is we offer a couple of modules that you just import this module into your code and you can access these things the same way without having to worry about where your app is run. And the next thing is for Universal React is handling of non-JavaScript code. If you're importing a JavaScript module, typically you can just import the code directly because it's JavaScript. But when it comes to things like images, fonts, anything that's non-JavaScript, then your import is going to fail. Webpack actually comes with there are Webpack loaders out there that makes this syntax work. But most of them only work on the client side. It doesn't work on the server side. So Electron offers a module called isomorphic loader that makes this possible on the server side. And once you can start importing all your images in your code, you will have to worry about getting your code into the CDN servers. Electron also takes care of that. Electron would extract any images you do import in your code, gather them up and upload them to the CDN servers, and serve it along with your app. It works locally and in production environments automatically. The next thing that Electron offers is optimization. The first one is pretty standard. It's just using Webpack's optimization plugins to minimize JavaScript and CSS files. But for server-side rendering actually uses the full version of React modules. And the full version of React modules is not minimized, it's not optimized. And if you know about React, it's a lot of React modules code is actually development-only code. You will see like no EV equals production, then do this, otherwise don't do this. That actually is very, very efficient. So to run in production, Electron will actually take the React modules, pass them through Babel to remove the development-only code, and use that copy instead of the original React copy to optimize your server-side rendering execution above the full rendering. So this is the technique where you render only the top visible part of your web page and then defer rendering of the hidden part. It works on both client-side and server-side, but on the server side, it's not always applicable because for SEO purposes, you would have to render everything anyways. But on the client side, when you only render the visible part and defer the rendering of the hidden part, then your user can interact with the visible part faster. Of course, if your user starts scrolling down immediately, then they will see the rendering of the hidden part as they scroll. And for optimization on the server-side rendering, Electrode offers a module called component caching. This is a pretty low-level hack on React itself. So when React 16 comes out, this will not work, and I'm not even sure if it's going to make sense anymore. But for now, with React 15, what it does is that if you, on your web page, if you have one component that gets rendered multiple times, then the component cache can actually just render once, cache the result, and then take that result and merge it with different properties to generate the final output. So here, let's say you have ABC that represent different smileys, and you have a layout like the ABC like that, and the component caching can take the result of a previous render component, merge it with the properties, and generate the final output. So that's a quick overview of some of the key features Electron offers. We have other features, like we support hard module reloading when you're developing, and we support building a progressive web app out of the box. We support CSS modules and so on. Next, I'm going to talk about how, within Walmart Labs, how we share hundreds of components across multiple teams. We have, like I said, we have dozens of apps that power Walmart.com. And we have, each app will have a team, and we have a lot of teams and a lot of developers. So a lot of the times, when one team builds a component, the chances are like a couple other teams would need the same component. And it would be very wasteful if every team builds their own component. So sharing components is very important for us. How do we deal with sharing components at such a scale, hundreds of developers, dozens of teams? So I'm going to talk about the process we go through here. The first key piece that Electron offers is a tool called Electron Explorer. What Electron Explorer does is that it would monitor our internal GitHub, or just any GitHub instance you have for a certain organization and for the React components you have. And if there's any update, it will automatically load them. So anyone can go to this web app and view and discover a component that's existing, and then they can actually do live coding right there. So you can see that on the top is the code, and then at the bottom is the output of those code. And it works on any component that exists in the GitHub repo and the NPM registry. And so when someone needs to build a new component, the first thing they typically do is that they come to Electron Explorer and play around, see what's out there. If nothing meets what they need, then it's time to build a new one. To do that, the first thing is to make a proposal. It's like pretty much like, hey, I want to build this component because I need it for these, and here is a markup of it. And then it would submit for review. Typically, if the component doesn't duplicate anything and makes sense, it gets approved fairly quickly. Once it's approved, then it's time to code up the component and build a component. Since we share component and share code across teams and a lot of developers, code review is a fairly big part of the process. What we do is we have a meta team. The meta team consists of developers from all the teams, and they typically responsible for daily code review. And the meta team's developer usually rotates out and on a volunteer basis. Once the meta team review the code and approve it, then it's time to merge a pull request, publish to NPM. And if it's a component, then Electron Explorer will automatically pick it up. And then from then on, you can discover that new component, and the cycle restarts. Okay, so that's all. Thank you. And
that was awesome.
so it's a very high level. I know there's a, sorry. a lot of details about these things, and it's published on our Walmart Labs blog space. It takes a little time for it to go through our internal review and process. So I do have a few that's in the pipeline, and I do plan to write more about these in the coming months. Thank you.
Thank you so much. That was really interesting. I feel like it's sort of like create React app like on steroids, like extra tough, create React app, yeah? Is that a good summary?
Yes.
Okay. Do we have any questions for Joel about Electrode or about Walmart Labs? You guys line up on all three sides. Or, well, there's two sides and then a center.
I'll be around here, so
we'll go this side first.
First of all, thank you for this wonderful talk. There was a slide in which you showed that there are multiple web apps which is powering the Walmart.com, and I was wondering like if you could share how are you persisting the state across multiple web apps. Like for example, I came to your search page, I searched for some products, then I went to your checkout page, so these all are separate apps which you suggested, and how the whole state persisted till the checkout process. Thank you.
Thank you. That's actually a very good question. Did everyone hear? So most of our apps are stateless, but they depend on the backend service, Java services, to maintain their state. Like for example, we have an account service, a user account. So when a user logs in, we drop an authentication token into the browser, in the cookies. So every time the user comes back, we take that token and try to authenticate that token with the account service. Then account service will come back with the data information. And the other thing is we use cookies, obviously. And so one of our internal projects is actually to build a session server. We have an initiative to build one Walmart. Basically, we want to allow the users to log into any device, on their phone, on their tablet, on their computer, on the desktop. They would have the same information, the same session that they left off. So we're going to be, unfortunately, making it more stateful than stateless, actually. But it's going to be like a session server in the backend.
We had another question on this side.
Thank you for the good presentation. The only question I have is that how easy you can use Selenium to integrate for testing performance or just the UI testing?
So for testing, we typically have, obviously, unit tests. And for automation tests, we use Selenium, and we have something called Armada. So we do have dedicated teams who write all these functional tests. Performance-wise, I don't have that data. Usually it runs on our build clusters, with running on Jenkins. And to be honest, it's not awfully fast. Usually these functional tests can take hours to finish.
Do you use your own?
Wait just a second.
Let's see. Oh, good. It talks. Did you create your own like CSS library, or do you use something like Bootstrap or Elements?
Internally, we use Sass. So all our CSS for our website is built in Sass because that's what was used before, and we have a whole library of Sass, and we didn't want to rewrite all that. So Electrode supports Sass, but Electrode supports all kind of variants of CSS loaders. We support CSS module, we support Sass, we support SCSS, and the Webpack config in Electrode is extendable. So we do have open source users who actually extend Electrode's config to support different kinds of CSS usage.
Thank you.
Great presentation. My question is about the component page that you have. Is there like a specific way that somebody has to build that component, that the page grabs it and displays?
Yeah, good question, actually. So all the components, we require them to have a demo folder. The demo folder would provide mark data and pretty much just a simple JSX code, a snippet that the Electron Explorer will load with mark data and to display for the demo. Of course, you can actually go to Electron Explorer, and there's that little box you can type in your code. You can type any code to get it to work. So the key is marking the data. Obviously, a component is not useful if you don't have the data for it to display. So that's the important part.
Everybody give a round of applause for Joel. That was very awesome.